This is video 933, and the goal here is to solve systems of conic sections. So the first thing is to kind of make sense of what does that mean. So what does it mean to solve a system? So this is something that you should know from the past. Solving a system means that you have, first of all, you have a set of equations. That's what a system is. Okay, so we have a system, which is a set of equations. To solve means to find when they have the same solutions. That's what it means to solve. We're looking for when they have the same solutions. So for instance, just a quick example, if I have two lines, maybe one line is y equals x, and maybe another line is y equals negative x plus 4. And so I would sketch that one, it would end up going downwards, of course. My system is the two equations that you see here. The solution is this one point where they cross. So it's a single point where we have the same x and y values. And the answer in this case is 2, 2. Because if I plug in 2 to both equations, if I plug it in here, I would see 2 equals 2. And if I plug it in here, I would see 2 equals the opposite of 2 plus 4. It's a solution to both of the equations. That's what a solution to a system means. So to make sense of what it means to solve a system, we're trying to find when they have the same solutions. Okay, all of the equations were given. We're just going to worry about 2 equations, but let's review the different strategies to do this. What I just did here was a graph. That's one strategy to solving a system. One strategy is to graph it, as you see here, and that's what I did in this example. Another strategy would simply be to guess and check. That would be like, okay, I have the 2 equations, let me just guess a number and see if it works. So I know y equals x, that's pretty easy. So if I plug in 5, I get 5 for y. Let's check if that works in the other equation. So if I plug in 5, 5, does it work? And we'd quickly see that it does not work because these two are not equal. So this is not the solution. This process would take a long time, guessing and checking. I do not want to guess and check, but if all else fails, guessing and checking is not a bad thing. Okay, so you guess a point and see if it works in both equations. Now, why guessing and checking, I mentioned it, is maybe you could guess and check after you have the graph. So maybe you graphed it like you see on the left here, and then you said, well, let me see if 2, 2 actually does work, and you could guess and check after you have it graphed. Now, in our situations, we're going to try graphing it for the first one, and then we will solve it algebraically. And the 2 strategies you learned in the past were elimination and substitution. So we will talk about how to use those strategies here in the first 2 examples. So in example 1, notice it's pretty complex. We got x and y again. It's an equation. We could graph it. So that's actually what we're going to start by doing. We're going to start by graphing example 1. I have to first figure out what kind of equations these are. So let's see. This first one, it's either an ellipse or a circle because I see the plus. And it must be an ellipse because they aren't all the same. But to put it in standard form, I have to divide everything by 4. So I'm going to divide everything by 4 and change this equation. That would end up canceling this 4. I'm going to get y plus 1 squared over 1 equals 1. That was why I divided by 4, to make that form 1. So now I could graph this equation on another set of axes over here. I can make a sketch of this graph. So this is an ellipse that's centered at 1, negative 1. It's got a horizontal axis of 2 because 4 is equal to 2 squared. So we're going to go over 2 and plot a point, and back 2 and plot a point. That's my major axis. And then we'll do the same thing for the vertical axis, but in this case it's only 1, so it's going to be up 1 and down 1. So here's my ellipse. So now I usually ask you to graph the focus, but the focus, is that important for this problem? The answer is no. It's not important for this problem. We don't care about the focus. This is not an application question. I asked you to graph the focus all the time just so you know how to find it. But for this particular application question, it is not necessary to know the focus. So I'm just going to skip the focus because my goal is to figure out where the problems intersect. So I've graphed my ellipse. That was the first equation. Now I'm going to graph the next equation. So let's just copy that down here and think about what this is. Looks like this is a parabola because only one of the quantities is squared. And I can see the vertex of the parabola is -1, -1. And then the parabola opens upward. I'm sorry, downward because of this negative here. So it's going to be -1 times 4. So my p-value is -1. So let's get a sketch of this graph. So we have this one here. -1, -1. So it looks like I already found one solution to my parabola, my system. And I'm going to go down 1 for the focus. And in this case, the focus is important, mostly because I need to graph the rest of this. And then I'm going to go backwards 1 for the directrix. Now this is not important because I do not need my directrix in order to see my points of intersection. But in order to get my latus rectum, I needed my focus. My latus rectum has a length of 4p. Since p is -1, it's going to have a length of 4. So absolute value of -4 is 4. So that means I'm going to go 2 to the left, 1, 2, and 2 to the right, 1, 2. 2 to the left and 2 to the right. Now I have my parabola. And notice my 2 key points popped up. Here's one point, that's the solution, here's the other. So my 2 solutions to this system is -1, -1, and then this other point, which was at 1, -2. The good news about systems is you can check your answer. So I could take these 2 solutions, and I could plug them back into the equations, and they should make both equations true. They should work in both equations. So graphing is an awesome strategy. Okay, it can take up some time on occasion, and sometimes we don't want to draw a graph, but we have to draw it if we're looking for the solutions. Now, the second strategy that we're going to look at is the algebraic strategy. So we just talked about guess and check, not a very good option, but we could do it. We've already looked at graphing it. Now we'll talk about solving algebraically. The second example lends itself to solving algebraically, mostly because I can substitute something right away, or I can use elimination. So I'll show you those 2 strategies so you can remember how to do both of them. So let's first talk about substitution. Just like the word means in English, it's going to mean something similar in math. We're going to replace, just like a substitute teacher replaces, we're going to replace something with what it's equal to. So in our equations, I noticed the first equation, I could solve that for x squared and see that x squared is 9 minus y squared. So substitution first makes you required to solve for some value like x squared. I don't even need to solve for x because what I'm going to do now is I'm going to substitute x squared in for this right here. That says 9x squared. So I'm going to take x squared and put it in for 9x squared. So let me copy down that equation. That was 9x squared y minus 1 squared equals 9. The ultimate goal with solving algebraically is to get rid of one of the variables. And the only way to do that is to substitute it out. So I'm taking out this x squared, and I'm replacing it with what it's equal to, this entire quantity. So with parentheses and all, I'm going to replace, I'm going to leave the 9 alone, but in parentheses, I'm going to put what x squared equals. And then everything else just gets copied down. Now notice the purpose of that was to get one variable. Now I just have y. Now I can solve for y. So now I can solve for the variable y and just find the values for y. So let's see. it requires us to kind of clean things up. This is going to be a quadratic because we have y squared. So I'm going to start by distributing the 9. 81 minus 9y squared. I'm also going to multiply this out. Please be careful with multiplying perfect squares. This says y minus 1 squared. So if I were to draw that out, it would be y minus 1 times y minus 1. I can do this in my head. If you can't, you need to be careful. So try it in your head and then check back in the video. Pause the video if you want to try it. This is what you should get when you multiply that out. If you're not convinced, do it with the generic rectangle that you see on the right. Now I'm just going to kind of simplify things out here. Negative 8y squared minus 2y. These two make 82, but I'm also going to subtract 9. You'll see why in just a second. So 82 minus 9, that gives me plus 73 equals 0. Maybe you're realizing why I did that now. To solve quadratics, which is this y squared term, is quadratic formula. So now I'm going to plug it into the quadratic formula and solve for y. So I'm going to plug in a is negative 8, b is negative 2, and c is 73. So try that on your own now. I'm going to quickly do that so you don't have to watch me do that, but that should be fairly simple. Opposite of b plus or minus square root of b squared minus 2a all over minus 4ac all over 2a. So hopefully you're able to use the quadratic formula to solve this one. Lots of common mistakes happen right here when we square the b value. We should get a positive answer 100% of the time right there. So that should have been 4, because anything squared is positive. And then we add 3,336 because that's what we get for this value when we simplify it. The two solutions happen to be ugly decimals. What that tells me is if I would have graphed it, I would have seen them crossing, but I would have not known exactly where. So graphing would not have been a good strategy here. Now I'm not done. All I found is 2 y values, so apparently there are 2 spots where it crosses. But these are the y values, so 2.9 is the y value, and negative 3.15 is the y value. I have to find the x value as well. Now I'm going to go back to one of my equations and plug it in. If you notice, this first equation is very simple. So I'm going to use that equation just because it's easier. So I'm going to use that equation and add the two. So in order to find the x value, x squared equals 9 minus y squared. I'm simply quickly rearranging it because I'm looking for x. So now it'll be a little bit quicker. So I'm going to plug in my two variable values, 2.9, and find out what x squared equals. And it looks like for this one I'm going to get 0.59. But remember, that's just x squared. I do need to square root both sides, so x equals plus or minus the square root of 0.59. Don't forget that it could be negative 0.59, the square root of 0.59, or positive square root of 0.59. So these two answers are 2 points, so it looks like we might have 4 points for our solutions. So one of them, the square root of 0.59, is 0.768. So 0.768, comma 2.9. And the other solution is negative 0.768, comma 2.9. Again, you can check your solutions by plugging in these entire points into the other equation. So remember, we used the top equation. Now you can plug it into this bottom equation and check if that works as well. It should work. Now we have one more variable to plug in. Again, we're going to use this equation that we saw up here. This equation that we saw up here with the x squared equals 9 minus y squared. And we're going to plug in, instead of 2.9, we're going to plug in negative 3.5. So it's going to be x squared equals 9 minus 3.15 squared. So we end up getting 9 minus, we end up getting a negative answer. Let's see, we're going to get 9 minus 3.15 squared is negative 0.9225. But I see x squared equals negative, so this is going to be two imaginary solutions. So they are not going to be solutions to our system. We're looking only for real solutions. So these are the 2 points that I would have seen if I would have graphed it. I would see them approximately crossing at 3 for y. But it wasn't quite 3. It was a little bit smaller than 3. So check those points. Make sure you believe that they work. There is one checkpoint I'm going to have you do. It's one I'm going to recommend that you graph. So try to graph and then submit your answers onto the Google form. So here it is, the checkpoint. Give these problems a try, and I would recommend the graphing method, and we'll practice more the algebraic method in class that will help us find those decimal answers. So good luck. Put the answers in the Google form so we can see how you did, and bring in those questions to class.